Hello and welcome to the second unit covering quantitative, qualitative, and mixed research. So just to give you a brief overview, we're going to begin by talking about different paradigms of research, and then we'll get into experimental research, non-experimental research, and then finally qualitative methods. So when we talk about a paradigm is sort of a way of thinking about the world. You can think about it as sort of the starting point of a set of researchers, their assumptions, their values that are sort of shared among a group of researchers. You can think about this as a shared view of reality or a worldview, just sort of a general understanding of the way that things work. For quantitative research relies on numerical data, quantifying things. These are things that can be counted, categorized, or anything that can be represented numerically. In contrast, qualitative research relies primarily on any other form of data that's non-quantitative. And typically this is going to be narrative kinds of data. Interviews, these kinds of things. For qualitative researchers, I really like this quote from Denson and Lincoln. They attempt to study things in the natural settings, attempting to make sense of or interpret phenomena in terms of the meanings that people bring to them. So as we'll talk about later, qualitative research is very often interested in finding sort of themes that help to sort of organize people's experiences. We'll get more into that. Mixed research, as you would imagine, is a mixture of both quantitative and qualitative research methods. Mixed research, it can be really useful for triangulation. So this is using both quantitative and qualitative methods to address particular research questions sort of as broadly as possible. We'll talk about this a little bit later on and sort of overcoming the strengths and weaknesses of each approach. We have multiple approaches. We can also use this to sort of explore and refine. So we may collect quantitative data to inform the development of quantitative measures. So, for example, I may be interested in developing a new measure of let's say social devaluation, the degree to which people feel devalued by society. And I may begin by collecting qualitative data. Tell me your experience of being socially devalued, and then use that information to find themes to develop measures. So these are just two examples of mixed research. Now, when we talk about quantitative research, experimental and non-experimental quantitative research, the basic fundamental building blocks or aspects of this paradigm are variables and data. So a variable is a condition or a characteristic that can take on different values. Basically, anything that we can quantify and measure, we can think about as being a variable. So stress. I could ask you on a scale of 1 to 10, how stressed out are you? Or I could take a blood sample and measure the amount of cortisol that's in your blood. And cortisol is a hormone that's released when we're under stress. Two different ways of measuring this variable of stress. Gender, age, all of these things are variables. Now, the data is the actual information that we collect. So the, parts per million of cortisol in your blood, you have 30 parts per million. I'm making this up. I'm not exactly sure how they do this, but 30 parts per million or 30 milliliters per whatever. This is your actual data. Your actual age is data. Okay. So we have variables and data. And when we want to do an experiment, we're going to collect data on particular variables in a particular way that will allow us to determine causal relationships, the degree to which one variable causes some change in another variable. And as we'll see, experiments are sort of key to understanding causality. We'll start with an example. Let's say I have a hypothesis that caffeine consumption improves mental functioning. I've sort of thought about my experiences, and I believe this this may be true, that caffeine consumption improves mental functioning. Now notice that in this statement here, I'm predicting a relationship between two variables, things that can take on different values. So caffeine consumption and mental functioning. Now, before I design a study, one thing we have to consider is what we call operational definitions for our variables. Earlier, when I referenced the stress example, I gave two operational definitions, two different ways that we can define how we will measure this, or what we will consider to be measurement for this variable. Oftentimes, the variables that we work with are abstract, so it's important to have these concrete procedures and definitions for how we will specifically measure the variable in our study. So an operational definition for caffeine consumption could be drinking 2 cups of coffee. Right, so for the purposes of this example, we'll define caffeine consumption as drinking 2 cups of coffee. And for mental functioning, we will operationally define this as a score on an intelligence test. Now, if we were doing this experiment for real, we wouldn't just say on an intelligence test. We would say the blah, blah, blah section of the Wechsler intelligence test. We would be very specific about exactly what we are measuring for our operational definition for intelligence. Now remember, when we have an experiment, we're going to make a prediction, right? We're making a causal prediction. We're predicting that one variable causes the other or will affect the other variable. Think about this in terms of changes in one variable. If I make a change in one variable, this is going to cause some other change in another variable. Now, in this example, I'm predicting that caffeine consumption could affect mental functioning. Caffeine consumption is going to increase mental functioning. However, it's quite possible that this could be the other way around, right? It could be the case that people who, if we observe that there's a relationship between caffeine consumption and increased mental function, right? As caffeine consumption goes up, mental functioning goes up. It could just be that people with higher levels of mental function just tend to gravitate towards caffeine for whatever reason, right? So even though we have this predicted relationship, this predicted causal relationship, we can't know whether or not one variable causes another without doing an experiment, right? And when we do an experiment, what we do is we manipulate one variable and observe its effects on the other variable. Typically, the variable that we think is doing the causing, the one that is causing some outcome, is the variable that we manipulate. In this example, we're predicting that caffeine intake increases mental functioning, so we're going to manipulate caffeine consumption. We're going to bring in people to our lab, to our research scenario, and some of these people are going to drink 2 cups of coffee, and other people are going to drink nothing. And then we're going to measure their mental functioning for both groups. Now notice in this example, we're manipulating one variable, and then we are measuring another variable. The one that we think that is being caused, the one that we think is the outcome, is the variable that we measure. Now I say this in this example, we manipulate one variable, we measure another variable, but that's not always the best way to think about this. So just hold off on that idea for a minute. When we talk about this, and you probably have heard these terms before, the independent variable is the variable that we manipulate in an experiment, or more generally or more broadly, it is the variable that is doing the influencing. So if we think about this in the simplest terms of X causes Y, X influences Y, X affects Y, the X in that statement is the independent variable. It is the thing that is doing the causing, the influencing downstream to the dependent variable. Now, in our study, the independent variable is caffeine intake because we think it's causing some change in mental functioning. Now, mental functioning is our dependent variable because it is the thing that is being affected. And the best way to think about this is in this X causes Y, X influences Y, the effects of X on Y. If you can conceptualize any research in terms of the X influences Y language, it's very easy to figure out what is the independent variable, what is the dependent variable. Okay. X influences Y, the IV influences the DV. Now, we're predicting that caffeine is going to influence increased mental function, but there are other variables that influence the dependent variable. In psychology and social psychology, we'll often say things are overdetermined, which means that there are many, many, many different variables that influence one particular dependent variable. So often when I teach this lecture face-to-face, I'll ask students, can you think of some other things besides caffeine consumption that might influence increased mental functioning? And if you spend a minute and you think about this, there's a lot of things that you might come up with. But one students don't often necessarily think about are things like hot water or the non-caffeine components of coffee, right? Because when you think about drinking 2 cups of coffee, there are two things. There's more than one thing that these participants are experiencing when they drink that cup of coffee, right? Yes, they're getting the caffeine, but they're also drinking a cup of hot water. They're also getting these non-caffeine components. And what we refer to these variables as, we refer to them as confounding variables. A confound is a variable that systematically varies with the independent variable and influences the dependent variable. And the key to a confound is this systematically varying with the independent variable. When we think about our research design, we have one group of people who drinks nothing and one group of people who drinks 2 cups of coffee, right? And what makes hot water and non-caffeine components of coffee confounds is that they systematically vary with the independent variable, right? The people in the non-caffeine group are not getting hot water or the non-caffeine components of coffee. And this is a problem for us when we're doing experiments. Confounds are a huge problem because they serve as an alternative explanation. So let's say we do our study and we find that the people who drank 2 cups of coffee scored higher on the intelligence test compared to the people who didn't. Well, we can't really know if it's the caffeine that caused that change, because it could be that just drinking a cup of hot water causes that change, because that is a difference between the two groups besides caffeine, right? So the way to think about a confound, it's a systematic difference between the two groups that varies along with that independent variable, right? It's not just that the caffeine group drank caffeine, but they also drank hot water and the non-caffeine group didn't. These are confounds. There are also these other variables. Now, when I asked the question initially, can you think of other things that influence increased mental function? These are the kinds of variables that students will talk about, right? Well, sensitivity to caffeine, or maybe the amount of sleep that they got the night before, or baseline level of intelligence, right? How smart you are just generally. These are all things that are going to influence that dependent variable, the scores that participants get on this intelligence test. But these variables do not systematically vary with the independent variable. These are things that participants bring to the research scenario themselves, right? They show up having not gotten any sleep or having gotten a great amount of sleep. But the key here is that these extraneous variables, they're not systematic, right? They don't systematically vary with the independent variable. And so we have a different way of dealing with these extraneous variables. So we'll talk now. How do we deal with confounds? How do we deal with extraneous variables? Well, the way that we deal with confounds is by making the groups as equal as possible. The key to experimentation is this idea of making our groups as equal as possible. Because what we ultimately want to do is we want our groups to be completely equal on all things except the independent variable. So one way we could do this in this example would be to brew up 2 batches of decaf coffee and then take one of those pots of decaf coffee and dose it with caffeine, right? So now both groups are going to drink the identical cup of decaf coffee, except one of those groups is going to have caffeine dosed into it and the other group isn't. If we were doing this experiment for real, we would get very detailed about how we even produce these 2 cups of coffee. So we would use the same exact coffee maker, and we would measure out the amount of water that we're going to use, and we'd measure out the amount of coffee that we're going to use. We'd weigh the amount of coffee, and we'd maybe even control the temperature to make sure that each group has the same temperature cup of coffee. And we would make sure that they're all drinking black coffee, right? Because maybe one group adds sugar and one group doesn't, right? So we want to make sure that no one's adding sugar, right? We want to make the groups as identical as possible on this variable of coffee, with the exception of caffeine, with the exception of the independent variable. Now, we have special names for these groups, the experimental group and the control group. The group that gets the treatment, right, is going to be the experimental group. The group that does not get the treatment, or that is our baseline, is our control group. It is the group that we're going to compare the experimental group to. So we call this the control group. Now, the experimental control that we've just used by making our groups as equal as possible eliminates these potential confounds, right? Both groups are drinking hot water. Both groups are getting all of the non-caffeine components. The only difference between those 2 groups is this independent variable, okay? So we've dealt with these confounds. The way that we deal with confounds is by making our experimental and control groups as equal as possible. But the way that we deal with extraneous variables is through random assignment to conditions, right? And what random assignment means is that each participant has an equal chance of being either in the experimental group or the control group. Okay. So maybe we say every other person who walks in the door goes to the experimental or control group. Or perhaps we use a random number system to randomly assign people, who are doing an online survey, for example, to the experimental group or the control group. But what's really cool about random assignment is that it ensures that all groups are equal before the treatment. It equalizes extraneous variables across groups. So, for example, if we have these 2 groups, and we have all of these participants over here. And, some participants got a good amount of sleep the night before. Some participants didn't. Some participants are smarter on average. Some participants are less intelligent on average. What happens when we randomly assign these people to groups is that we equalize these variables across groups. So some people in this group got a good amount of sleep, but some people in this group got a good amount of sleep. And some people in this group are smarter than average, and some people in this group are smarter than average. By randomly assigning people to groups, what we do is we get an equal distribution of these variables in both groups, right? So if we ask group A, how much sleep did you get the night before? And we ask group B, how much sleep did you get the night before? On average, they're not going to be significantly different. And this is especially powerful with larger sample sizes, right? We equalize these groups. So in terms of our dependent variable then, if we just randomly assign these people to groups, and then we gave them both an intelligence test, what we would find is that the 2 groups would be 100% equal on this intelligence test without us doing anything, because we've equalized baseline level of intelligence across both groups through random assignment. Now, when I say equal, I don't mean like 1-to-1, right? Group A isn't going to score 100 and group B isn't going to score 100. What I mean is that they won't be significantly different, right? The distribution of intelligence in both groups will be roughly equal. And so what that means is the average intelligence test score for group A will be the same as the average intelligence test score for group B. And again, when I say the same, I don't mean identical, I mean not statistically different. Okay. Now, So we've controlled for extraneous variables using random assignment. We've controlled for confounds um, by making our two groups as identical as possible. And so what happens now is if we randomly assign these two groups, we know they're equal in intelligence and all these other extraneous variables, and then we present our manipulation. Both groups drink the same exact cup of coffee, but one of those groups has caffeine dosed into it. If we observe a difference between those two groups, the intelligence test is higher for the experimental group than the control group, then the only possible explanation for why that difference exists would be the presence of caffeine. And this is why experiments can provide causal evidence. By making the two groups equal at time one, and by making our two conditions as equal as possible except for the independent variable, the only plausible explanation for any differences in the dependent variable has to be that independent variable. And thus we can conclude that caffeine must be causing this difference in intelligence because there is no other explanation. Now, what's cool about random assignments is that we assume that the groups are equal in the dependent variable before the manipulation. And what this means is we don't need to actually measure the dependent variable before, right? We don't need to know what their score on intelligence was before the manipulation because we know that both groups are equal. Now, we could do that study. We could say, how does your particular intelligence score change following the manipulation, right? We could measure that beforehand to verify that random assignment works, but we don't have to do that, right? Because the groups are equal beforehand, any differences after the manipulation have to be due to the manipulation. Because we've controlled for extraneous variables with random assignment, and we've controlled for confounds by having a very tightly designed experiment. Random assignment's pretty awesome. Okay. Now, there are other kinds of variables that we run into when we do experimental research. Your textbook classifies these as intervening variables. Intervening variables are what we talk about as mediators or mediating variables. And this implies sort of a causal chain of events. So A happens, then B happens, then C happens, right? And so B in this case is what we refer to as a mediating variable. So for example, I did some research on apologies and forgiveness, and I was interested in the idea of whether or not perceptions of stability would influence or would mediate the relationship between remorse and forgiveness. So one thing we know from this literature is that the more remorse someone shows when they apologize, the more forgiving you will be. And what we suggested in this paper was that remorse functions to convey the message, hey, I won't do this again. And we refer to this as behavioral stability. And so what we found in this paper was that behavioral stability mediates the relationship between remorse and forgiveness. Right. So you think about this, someone apologizes, they're remorseful, A, and then B, you feel like, well, they're probably not going to do this to me again, then C, so therefore I forgive them. Right? This is sort of a mediating relationship or a mediating prediction. Okay. Now, in contrast, here we go. Sorry, I forgot I had this example in here. So perhaps therapy leads to specific coping strategies, which then in turn lead to a decrease in depression, right? Now, in terms of statistical analysis, what this looks like is that we might find that people who participate in therapy compared to a waitlist control have significant decreases in their depression symptoms. And then if we measure coping strategies for both our experimental and our control group, what we may find is that the relationship between therapy and depressive symptoms diminishes when we include coping strategies into our model. And what this suggests is that the path from therapy to diminished depression goes through coping strategies, right? So this mediates this relationship. In contrast, we can talk about moderator variables. Moderator variables are typically when we are predicting statistical interaction effects. If you don't know what that means, don't worry about it. You will learn about that when we learn about statistics. Maybe a little bit later on in this course, you might touch on it a little bit more. But the way to think about a moderating variable is if a mediating variable goes in between two variables, a moderating variable is more like a volume knob. It sort of turns up and turns down the effects of the independent variable on the dependent variable. So for example, in this therapy example, perhaps we find that there's a relationship between therapy and decreased depression. So the people who are in the experimental group and receive the therapy, they have significantly decreased depression compared to the control group. But this is moderated by gender, which means that gender changes how this relationship works. It works better for males rather than females. You can sort of think about in terms of the forgiveness example that I used before. Empathy might be a moderator between apologies and forgiveness. So in general, when someone apologizes, we're more likely to forgive. And for people who are high in empathy, who can experience other people's emotional pain, this may turn up this effect. It makes the effect of apologies and forgiveness stronger compared to people who are low in empathy. It might turn down that effect. It might make that effect weaker. So the key here between a mediator is a mediator goes in this causal chain, whereas a moderator is sort of like a volume knob that turns up or turns down the effects of the independent variable on the dependent variable. Your book gives a really good table of this, so I have this here just for your notes, where we talk about all these variables, except for confounds for some reason, which I'm not quite sure why the book doesn't have that in here, but I talk about it because it's important. Now, when we're talking about non-experimental research, by definition, a non-experimental research design has no manipulation of an independent variable, and because we're not manipulating anything, it makes it more difficult for us to draw conclusions about causality, to suggest that one variable causes another. We'll talk about two examples. So causal comparative, where we have an existing categorical independent variable that is influencing some quantitative outcome variable. And then we'll talk about correlational research, where we have two quantitative variables. So when we're talking about causal comparative, we're looking at the difference between groups on some continuous or quantitative outcome variable. Now, this is similar to our experiment, right? In our experiment, we had a categorical independent variable, caffeine group, no caffeine group, experimental control, and we had a quantitative outcome variable. This would be the score on an intelligence test. Now, in causal comparative, the key difference here is that the independent variable is using existing groups, right? So we're not manipulating people to these groups. They already exist. So gender and class performance. We might be comparing males and females. We obviously can't randomly assign people to be male and female. And so we talk about these as being non-equivalent groups. Because we can't randomly assign people to these groups, we can't be sure that they're equivalent at time one. And this makes it much more difficult for us to determine causality. When we're talking about correlational research, we're looking at a relationship between two variables. Notice the difference here. Notice the two red words on the slide, right? For experimental research and for causal comparative, we're looking at a difference between two groups. With correlational research, we're looking at a relationship between two variables. So the relationship between self-esteem and class performance. Maybe we predict that people with higher self-esteem are going to have better performance in class. Now notice here we say self-esteem is the independent variable and class performance is the dependent variable. But when we're talking about correlation, we don't really think about independent and dependent variable because we really can't determine anything about causality with correlational research, which we'll talk about here in a minute. Now, just to give you a brief primer on correlation, correlation, the statistic, typically denoted R. Pearson product moment correlation is the one we're most commonly going to see. This can range from -1 to +1 with 0 in the middle. It cannot be higher than 1 and it cannot be lower than -1. Correlations have both strength and direction. So the closer your correlation gets to 1 or -1, the stronger it is. And the direction, the negative or positive, tells you what the direction of the relationship looks like. So a -1 is a perfect negative relationship. And an example of this might be the time it takes to drive somewhere versus how fast you are driving. We won't talk about red light cameras and traffic and wind resistance and all these sorts of things. But generally speaking, as you increase the amount of speed in your vehicle, as you go faster, the amount of time it takes to drive a fixed distance is going to get smaller and smaller. And when we look at a scatter plot of this, we'll know that this is a perfect relationship because all of our data points are going to sit right on top of this line. Now, it's perfectly negative because increasing in one variable is associated with decreasing in another variable. On the other side, a perfect positive relationship, with most of us are familiar, is the relationship between the number of hours you work and the number of dollars you get paid. So if you work at Starbucks as a barista, as I did when I was in graduate school, and if you get paid $10 an hour, that means that as we increase by hours, we are going to increase the amount of money that we make. And it's a perfect positive relationship because all of the variability in the amount of dollars that you get paid is 100% related to the number of hours you work, right? Nothing else influences how much you get paid other than how many hours you work. And this is what makes this a perfect positive relationship. Okay. And again, increasing in one variable is associated with increases in another variable. Now, in the middle, when we have no relationship, right? No relationship means that the variables are completely unrelated, right? So we might look at the number of pets you have and your body mass index. These two things are completely unrelated, right? And when we look at a scatter plot of unrelated data, it's just going to look like a big blob. It's going to look like sort of a shotgun pattern, data points all over the place with no sort of discernible pattern. Knowing something about And this is because knowing something about the number of pets you have does not tell me anything about your body mass index or vice versa. Now, when we talk about correlation, we're really interested in this idea of covariance. And covariance is just a fancy way of saying the degree to which two variables vary together, the degree to which two things are related. So, for example, we know that there's a relationship between height and weight. Generally speaking, it's positive. As we get taller, we also get heavier. When we think about this conceptually, this is the degree to which these two variables vary together related to the degree to which they vary separately. So if you think about this in terms of a Venn diagram, you can think about the variability of x and y separately. So you can think about, and I'm sorry if there's math on here, there will be no math questions, but it's just a way to think about correlation. So we think about this. If you think about these two circles as representing all of the variability in height and weight. So this x represents all the things that influence your height, and this y represents all of the things that influence your adult weight, right? So imagine that conceptually we could come up with a big long list of all of these things. And if you imagine that this is 100% and this is 100%, genetics might influence 10% of your adult height and so on, okay? So if we can imagine all the things that influence height and weight separately, And then we can see to what degree there is overlap or to what degree these things are related that influence both height and weight. This is the covariance. This is what we're interested in. So, for example, whether or not you had a giant pile of food at the Grand Lux Cafe downtown last night, it's going to be something that'll probably affect your weight, but it's not going to affect your height whatsoever. And so this would be variability in weight that's unrelated to variability in height. But genetics, perhaps the content of your diet while you were growing up, these are things that are going to influence both height and weight together. And those things go here in this overlap portion, the covariance. Okay. Now, bringing this all together then, when we have two variables that are strongly related, now we're not talking perfectly like the hourly wage data, but when we have two things that are strongly related, as this correlation gets closer to 1, we get stronger and stronger. We can imagine this as being a high degree of overlap between the two variables. When we're talking about height and weight, especially in children, there's a really strong relationship between height and weight in children. As children get taller, they also get heavier, right? So for children, there is a huge covariance of X and Y, of height and weight, right? Height is strongly related to weight. This correlation of 0.94, it's close to 1. That means it's a strong positive relationship. In contrast, if we looked at the BMI versus number of pets, there's very, very little overlap. The things that influence how many pets you have and the things that influence your BMI are completely separate. They're unrelated. And so there's very, very little overlap. So our correlation is very low. It's very close to 0. So generally speaking, the stronger the correlation, the higher it's going to be, the closer it's going to be to -1 or +1. The weaker the correlation, or the weaker the overlap, or the weaker the relationship, the closer it's going to be to 0. Now, usually I put this up in class, and when I give this lecture face-to-face, and I sit there and I let students kind of think about it and see if they can get the joke here. The idea here, and I'll let you sort of think about it. The idea here is that correlation does not equal causation. In your book, we talk about the 3 things that are required for causality: temporal precedence, internal validity, and covariance. Temporal precedence means that X has to come before Y, which makes sense. And internal validity is essentially ruling out all possible confounds. We make our experimental group and control group as equal as possible. But that third thing is correlation, right? There does have to be covariance. But covariance is not enough. Just because 2 things are related doesn't necessarily mean that one of those things causes the other. So, for example, there is, and this is true, a significant positive relationship between arm length and IQ in children. As children's arms get longer, they also get smarter. Now, does this mean that arm length causes an increase in intelligence? Or does this mean that intelligence causes an increase in arm length? No. There's a third variable that influences both of these things, and that is age. Children who are younger have shorter arms and they have lower IQs than children who are taller. They have longer arms and they know more stuff. Another example of this is the relationship between ice cream sales and drowning. As ice cream sales go up, drownings also go up. This is not to say that ice cream sales cause drowning, right? It's not that people are drowning while swimming and trying to hold their ice cream out of the water. It is also not the case that drownings cause ice cream sales. People are so sad that their loved ones are dying from drowning that they're going to buy ice cream, right? What is happening here is that it is summertime, and in the summer, people are more likely to die from drowning and also more likely to eat ice cream. So just because 2 things are related does not mean that one causes the other. And this is just a cautionary tale. You have to be careful of this kind of language, especially in the popular media. You will often hear media reports of, there is a new link between X and Y, or researchers have found an association between X and Y, right? And just because 2 things are related doesn't necessarily mean that there's a causal relationship. We can only determine causality by a well conducted and controlled experiment. Now, when we talk about qualitative research methods, we're moving completely to the opposite end of the research spectrum. We're no longer interested in variables per se. We're no longer interested in quantifiable numeric data. Now we're interested in narrative kinds of data. So phenomenological qualitative research is interested in understanding how people overall experience phenomena. So we interviewed 20 widows about their experience with the death of their husband, and then we look for common themes. When we read through each of these interviews, what are some of the common things that people experience? And we can use that to understand the phenomenology of the death experience. Ethnography is another form of qualitative research where we're looking at the cultural practices of a group. So interviewing people about what is important to their particular group, shared attitudes, values, these kinds of things. I believe I've said before that quantitative research is my area of expertise. Qualitative research is not. So I will do my best with the qualitative research, but just know as I go through this that it's not necessarily my area of expertise. So for example, you might go and spend some time in a specific community and document their culture and their educational practices. This would be sort of qualitative research. Narrative inquiry is asking people to tell stories about their experiences so that we can figure out what is driving a particular phenomena or experience. So this might be asking students to tell stories about what made them successful in school. For all of these qualitative research methods, one sort of key aspect of this is that it's open-ended. We're not asking people to rate things on a scale. We're not categorizing people. We're asking people open-ended questions, and then we're recording, typically audio recording, their responses, and then transcribing it and looking for common themes and patterns. In a case study, we're looking at a detailed account of an individual or one or two specific cases. This may be examining a few students in a classroom about new curricula-related technology use. Oftentimes, case studies are used for rare phenomena, right? So something that happens that's not very common, we would like to learn more about it. And so we'll find someone who's had that very rare or unusual experience, victims of torture, for example. And we will ask them to give detailed detailed information about their experience so that we can learn about that very rare experience that they've had. Now, grounded theory is when we are using this narrative data, we're using qualitative data to generate a theory, to generate overarching explanation for how and why some pattern exists. So, for example, maybe we find parents who have removed their children from the public school system, and we interview them and look for common themes to develop an understanding of why parents might do this. When we're using qualitative research to address this how and why question, this is more of a grounded theory approach. And then finally, historical approach, where we're looking at sort of in an archival fashion studies of people and events from the past. So looking at corporal punishment, for example, and perhaps maybe how this has changed over time. Now, when we talk about mixed research, as you would imagine, is a mix of quantitative and qualitative methods. In one study, perhaps a series of studies. So, for example, we might be interested in asking the question, how does school climate affect graduation rates? Right? How does the way that kids experience school. Is it a positive climate? Is it welcoming? Do they feel like they have a voice? These kinds of things. How does that influence graduation rates? We might use survey methodology to measure variables that predict graduation rates. So we might ask questions about attendance. We might ask questions about, you know, you know, the degree to which they feel like they can trust their teachers and the administrators, the degree to which they feel like they're supported by the teachers and the administrators. We might even do an experiment. So we could do what's called the gold standard in education research, which is a randomized controlled trial, where we randomly assign different schools to different levels of an experimental manipulation to observe the outcome, see if we can influence the school climate. And then we might also conduct narrative inquiry interviews. So we might, in addition to this quantitative measures, we might ask them narrative, open-ended narrative type questions and interviews to look for common themes that may not necessarily be picked up using these more closed quantitative measures. And this is one of the really big benefits of this mixed approach to research, is that qualitative and quantitative methods can complement each other by overcoming the strengths and weaknesses of each design. So, for example, one criticism of experimental research is that it is does not have a lot of what we would say is external validity, which we'll talk about. Just sort of does this very controlled, rigorous experience in a laboratory generalize to how people live in the real world. If we did a study where we had experimental evidence that suggests that, for example, experiencing social rejection leads to aggression, and then we had some qualitative research where we asked people to talk about their experience of social rejection, and we found similar patterns, right? Then what we can say is that these two studies sort of triangulate, they sort of overlap and point to this same truth that experiencing social rejection can lead to aggressive responses. The metaphor that your book likes to use is that if you have a bunch of different fishnets that all have holes in them, if you use all the fishnets at the same time, the holes are not in the same places, and so you catch more fish. And this is the idea of sort of a corroborative approach. Is when multiple methods produce the same patterns and the same results, we are much more confident in those patterns than if we have just experiments or just qualitative research. Other things that are useful with this is that, this is mostly what I've already said, but using mixed research complements these different perspectives and allows us to capture more of the variability in whatever we are trying to study and provide a richer understanding than one particular method on its own. So just to kind of sum up all of the things that we've talked about, at this first level, this is a figure from your book, at this first level we have these paradigms. Paradigms are these overarching worldviews, so quantitative research, mixed research, qualitative research. And then at this second level, we have these various methods that fall under these different paradigms, so experimental and non-experimental research, and then the various qualitative research methods. So that is it for this lecture. As always, please feel free to email me if you have any questions or concerns.